A fish just pointed at something. Not a signal researchers projected onto it after the fact, an actual deliberate gesture aimed at a completely different species, meaning, look here. It's one of the only fish ever documented doing that, and it isn't even the strangest partnership on this list. In the forests of Mozambique, a small brown bird will fly directly toward a human, land close enough to be impossible to ignore, and call out loudly and repeatedly because it wants something from you and it knows exactly how to get it. This isn't a territorial display. It isn't confused about what a human is. It's the opening move of one of the strangest working relationships in the natural world, and it has existed for so long that both species involved have evolved specific behaviors just to keep it running. The bird is called a greater honey guide, and what it wants is access to a beehive it cannot open on its own. Honey guides eat beeswax, but bee nests are usually sealed inside trees or rock crevices, defended by stinging swarms the bird has no way to get through. Humans, on the other hand, can smoke out a hive and break it open, but usually have no idea where a hive is hidden in miles of forest. In 2016, researcher Claire Spottiswoode published a study on the Yao honey hunters of Mozambique, who use a specific vocal call, a sharp trill followed by a grunt, passed down through generations specifically for this purpose, to signal to honey guides that they're ready to be led to a hive. Spottiswoode played recordings of this specific call alongside recordings of random human speech and other bird sounds, and found honey guides responded to the trill grunt call roughly 3 times more often and led hunters to a hive successfully at a significantly higher rate compared to any other sound tested. The bird doesn't just react to any human noise, it recognizes a specific signal that means, I am ready to work with you, flies ahead in short hops, waits for the human to catch up, and repeats this the entire way to the hive, sometimes over a kilometer of dense forest. Once the humans break the hive open and take the honey guide gets what it actually wanted the whole time: the wax and larvae left behind, food it could never have reached alone. Underwater, groupers have built a version of this same partnership with an animal that isn't remotely closely related to them. Grouper fish hunt in open water during the day, but their prey often escapes into narrow reef crevices. The grouper's body is too large to enter. Moray eels can fit into those same crevices easily, but hunt primarily by scent at night and often miss prey a grouper could see clearly in daylight. Researcher Redouan Bashari documented groupers actively recruiting eels for cooperative hunts using a specific signal. The grouper performs a rapid, exaggerated headstand, shaking its body while pointing its head directly at the crevice where prey is hiding. Shari's team found this wasn't a random display. Groupers only performed the headstand signal when a moray eel was nearby and when prey was actually hiding in a crevice the grouper itself couldn't reach, and eels responded to the signal by moving toward the indicated crevice at a significantly higher rate than to unsignaled encounters. This was the first time researchers had documented a fish using what functions as a referential gesture, pointing at something specific for another animal to understand, a category of communication previously associated mainly with primates. Coyotes and badgers run a hunting partnership that looks almost like division of labor. Both species hunt the same prey, burrowing rodents like prairie dogs and ground squirrels, but they're built for opposite halves of the job. Badgers are powerful diggers who can excavate a rodent directly out of its burrow, but can't chase down anything that escapes above ground. Coyotes are fast runners who can easily catch a fleeing rodent in the open, but can't dig one out of a sealed tunnel. Researchers observing coyote-badger pairs found that when hunting together, prey animals had far fewer viable escape routes than when either predator hunted alone. The badger blocks the underground option, the coyote blocks the surface option, and prey caught between the two has nowhere left to go. Camera trap studies have documented these pairs traveling together, resting near each other between hunts, and in some cases appearing to actively wait for one another before beginning a hunt, behavior that goes well beyond two predators simply happening to target the same area at the same time. Pistol shrimp and gobies run what might be the most tightly coordinated interspecies relationship of all, built around a disability neither species can fix alone. The shrimp is a skilled tunnel engineer, excavating and maintaining an elaborate burrow in the sand, but it has extremely poor eyesight and can't see approaching predators. The goby fish has excellent vision but can't dig a burrow of its own to save its life. So the shrimp builds and maintains a shared home, and the goby stands guard at the entrance, watching for danger while the shrimp works, one antenna almost always resting directly on the goby's body to stay in constant physical contact. When the goby spots a predator, it flicks its tail in a specific pattern the shrimp can feel immediately through that antenna contact, and both animals retreat into the burrow together within a fraction of a second, the shrimp reacting to a threat it never saw at all, purely off a signal relayed through touch from an animal watching on its behalf. What connects a bird that recruits humans, a fish that points, a predator pair that blocks two escape routes at once, and a shrimp that outsources its own eyesight to a fish is that none of these are accidents of proximity. Each relationship requires a specific signal sent by one species and correctly interpreted by a completely different one, evolved and maintained because both sides get something they cannot get alone. Researchers studying interspecies cooperation are careful to note that none of these partnerships require the animals to understand each other's inner experience or anything resembling friendship in a human sense. What they do require is far stranger in its own way: two separate nervous systems shaped by tens of millions of years of separate evolution, converging on a shared communication system precise enough to function like a functioning contract, honored without either species ever being taught the terms. So somewhere right now, a honey guide is watching a stretch of forest, waiting for the right call. A shrimp is digging with its back turned, entirely dependent on a fish it cannot see clearly, trusting a tail flick it will never misinterpret. These aren't relationships built on affection. They're built on something closer to infrastructure, two species running a system neither one could operate alone, and neither one ever needed language to agree to.